Yeah, hi, and all. So people are joining, right? This link.
I will notify in the group.
Yeah, yeah. Please notify once because already 101. People are joining slowly. Still notify once, and please put your attendance no in that chat box. Okay. You guys have doubts in regarding the last class, last session. Any doubts you ask me, you can ask me. Okay, I think today we are good to go. Then 7 people already are there. You please notify. I think the people who are remaining. Okay. I think 5 or 6 people may be remaining. Okay, so let's start sharing the screen. Better. Yeah. Okay. So, guys, just before beginning today's session, I want to just ask you one very simple thing. So, like, do you have any idea about the grain? The grain size. What do you mean by the size of a grain? I mean, what do you mean by a grain, first of all, in a microstructure?
So, like a grain in a microstructure is something like it's an aggregate of similarly oriented atoms.
Atoms. Is it
Uh,
atom?
okay, unit cell.
Ah, okay.
Yeah, yeah.
So,
So,
like in simple words, we can say that when there is a polycrystal, then two crystal structures are separated by the grain boundaries, and each
uh-huh.
crystal structure is called grain.
Yeah, right, exactly. I mean, you can say that each crystal's not structure. Each crystal is called a grain, not structure. Structure is so when you talk of structure, you talk of symmetry and all. You are not talking of symmetry when you're talking of grain. You are, of course, when you're talking of the orientation, then you are talking of the structure, talking of the symmetry, thousands of things. But especially when you talk of a grain, you are not talking of structure. But okay, you can say that each in a polycrystalline material, each and every crystal, each and every grain represents a crystal, right? Because it has got all the atomic planes, not all the atoms rather, because it has got all the different atomic planes in the same orientation. I mean, not in the same, rather to say, there is a fixed orientation, not same orientation, rather there is a fixed orientation of the atomic planes, right? I mean, what separates, so now tell me one thing. So what separates one grain from the other? What separates?
In boundary.
Grain boundary. So grain boundary. So how will you define it then?
So it's a planar defect, basically,
Okay.
and it's the junction at which like the layer of particles with different orientations they meet.
Layer of particles, you can say, or should
Array,
we
yeah, yeah.
layer
Exactly.
of grains? The
Yeah,
grains with
yeah.
different orientations. You take one grain with a particular orientation of the atomic planes, and you take
Yes.
the other grain with another orientation of the atomic planes. So you're trying to make them meet at a junction, or whatever you said, like
Yes, yes.
effect. So that's okay. Okay, good. So, okay, now I think then you have the idea. So, just tell me, like, has Sir taught you about the grain size then? The grain size then? Do you know?
Yes, sir. Like we discussed some methods. Like one of
Like,
them, yeah, obviously was this one. So yeah.
linear intercept method, okay?
Uh, I mean,
And
we just discussed like how do we determine, like firstly we saw that like how do waves actually look, and like what scale are we dealing and all that.
okay.
Then we like saw that like, so did mention that like we have certain methods to measure grain size and all that. So,
Yeah, okay, okay. So, today, like, there are a number of methods, okay? There are, okay, now let me ask you, how many methods are you aware of? Like, how many methods did Sir tell you? Sir told you any? How
sir, I'm
many?
not sure of the number actually. Like the number
Okay.
of
Like
methods.
which methods do you know? This method is okay. This method linear
Mm.
intercept is very common. Okay. Then the other one. Any idea? Okay, fine. So, and I'll start today. Okay, so linear intercept method, I think you guys have some idea, but I will tell you a bit more. So what you generally do is that you say, suppose you have a microstructure, you have a suppose a section of a microstructure, like you see all the crystallized grains here, recrystallized grains. You see, you have so beautiful microstructure. You have twins here. You have different contrast grains in this microstructure and all. So what exactly you need to do is that you have to find out the this is one of the methods where you have to find out the size of the different grains. Okay, so I mean the average size, not of the different grains, rather the average size, grain size in a given microstructure. So what you have to do, you have to draw a number of lines. Okay, I mean generally you can draw. Generally the convention is you have to draw lines from one end to the other end. Here, just in order to make it appear the entire line to make the entire line appear here. So what I did is that I did not draw this line ranging from one end to the other end of the microstructure, but this is also not wrong. But then that will give you more statistics, because I will tell you that suppose you have drawn a line here, line L1, you have a line L2, you have drawn line L3, L4, L5, L6, L7. So you have drawn a number of parallel lines. Okay, you draw a number of parallel lines in a given microstructure. And the length of each and every line is actually equal, right? If it is a parallel line. But definitely when you draw it, okay, with your own hand, you will find that maybe, see, geometrically a lot of things are ideal. Okay, like L1 is equal to L2 is equal to L3 is equal to L4. But the main thing is that it may not be the case all the time, because maybe if it is, suppose the first line length is around 12.1, if it is parallel exactly, maybe it will be around, some error bar will be there. Okay, so maybe 11.8 or 11.9 or something. So that is the reason I put L1, L2, L3, L4, L5, L6 or L7 all different. So what you can do, you can what you do, suppose you have drawn around 7 lines. So what you do is that total length of the lines is equal to L1 plus L2 plus L3 plus dot dot till Ln. I mean for n number of lines. If it is 7 lines, then you draw till L7. L1 summation of L2 from L1 to L7, right? I mean that is the length of all the lines. Now once you draw all the lines, now what you have to do is that n. What is n? Capital N. It is nothing but the number of intersections between all the lines and the grains. I will explain this to you. Suppose you consider line 1. Okay. Okay. So now let me ask you, how many intersections do you see between this line 1 and the grains? Okay. Just anyone. Between line L1, you are looking at line L1. Okay, the top one. So here you look at line L1. How many intersections do you see between the grain boundaries? I mean, this all the grain boundaries. No, these are these one.
Approximately 8.
8, right? So similarly, you will also see, you will see the number of intersections also. Here you have to count. Here also you have to count. Here you have to count. So for all the 7 total number of intersections you have to count with the grain boundaries. Okay, of all the lines with the grain boundaries. So that will give you the total number of n. That is the number of intersections between all the lines and the grains. Okay, that is important. Now, the other thing that is important is, I mean, how to find out. You see, we are ultimately interested to find out what. We are interested to find out what is the average grain size. So for that, we have to find out the mean intercept length. That is a D. So how do you find out D? I mean, I will tell you. So D is equal to nothing but L by Nm. L by Nm. What is L? L is, I told you, length of all the lines divided by what is N? Number of intersections between all the lines and the grains, right? And what is M? M is the magnification. Okay, did I not write this? Oh, I didn't write this. Okay, so you just make a note that M, capital M is the magnification, capital M. So this is the capital M. So whatever, suppose this is 100x, so you put it as 100 into, I mean, you suppose N is equal to 56, and then what is L? L is suppose maybe some amount. So you will get D, right? That is the mean intercept length. And then once you get the D, how to find out the average grain size? So this is capital D is equal to 1.5D. This is the standard convention that is being used. I mean, this 1.5. Now the question is, you may ask me, why am I using 1.5? 1.5 is actually going to come from the ASTM standard. So I mean, there are a lot of ways you can find out this 1.5. We are not going to deal it today because that will be a totally different topic. So capital D is equal to 1.5D. Okay, so always remember. So this is the simplest. I mean, this is one of the simplest methods to find out the grain size, average grain size. Okay, so this is understandable. This much you have understood.
Okay, sir.
This one, the remaining guys, yes or no?
Yes, sir. Yes, sir. Yes, sir.
Okay, fine. So if this is clear, then I can talk about the other. So this is the most the most used method, because mainly what we do, I will tell you. So since we are doing PhD, I can tell you one of my experiences. It's like when we are dealing with, when we are getting the the different microstructures. Generally, for suppose you take an optical image, or you take an SEM image, okay, scanning electron microscope image. You take it, and you have suppose an etched microstructure where you see all this is a very very rare case. I mean, this is one of the best microstructures ever that we get. But in many materials you may not get this kind of a condition also may not be persistent, like they cannot be may not be seeing this kind of grains also. So there, what you can find, I mean, in general, what you have to do is that the linear intercept method, if you apply, you will be able to find out the grain size, the average grain size from a given microstructure. I mean, mostly researchers use this method only. I mean, this is the simplest method ever possible. Okay, now the other method is that, oh sorry, I think magnification came much later. This animation sequence went a bit wrong. Okay, I will put it now in the beginning. Okay. Now the other method is called the planimetric method. Did sir give you any idea about that? I just want to know. Any idea do you have about this method?
I think it's about the area, right? Like we find the average area covered by one grain.
Okay. Yeah, it's basically based on the area. I mean, I'm just going to talk about today, like, okay, that is the principle, but how do you execute it? I will tell you. So it's a very simple thing. So nothing. I mean, you take a microstructure, a section. What do you do? You have to initially draw a circle of diameter equal to 79.8 millimeter. And generally, what people do is that they do it. It is like it may be quite hard. Today, the classwork that I'm going to give you, there I will make it easy for you. I mean, you cannot draw, right? I mean, if it is in micron scale, if it is a micron scale bar, it may be hard for you to draw in 79.8 millimeters. So I will make it make the classwork, I will explain the classwork, and then you can do it. But then I will explain this method to you. So suppose you have a microstructure. Okay, let me complete this. So you have a microstructure, and you draw a circle which is having the total diameter equal to 79.8 millimeter. This is the diameter. So maybe this is the 79.8 millimeter or a dia in this entire microstructure that you have drawn. So now it is important to know a certain number of terms. The first is N1. What is N1? N1 is nothing but the total number of grains within the circle, completely within the circle. Can you, any one of you, can you count the total number of grains in this case, which are within the circle? Which are completely within, okay? Which are through, that is through which the circumference is not passing. I mean, those grains where it is passing, they are not N1.
So some grain boundary is not that clearly visible.
No. Suppose I will tell you. Suppose you see my cursor. So suppose this grain, okay, this grain. You just consider this. If it is open, then you consider this as closed. Okay, don't worry. Okay.
Sir, approx 30.
30. Okay. Again, can you recount once? Recount a bit. Not 30. I mean, a bit less.
So around 20.
Yeah. I mean, it is around 24 grains actually. Within inside, you have around 24 grains. Okay, and so that is N1. Okay, now make a note of it. I mean, I'm just giving you an example so that you can execute this thing. So N1 is equal to 24, suppose, and then so that is the number of grains within the circle, which means that suppose I will give you, like I will explain. Suppose this is the grain. So like you see this grain, if you are able to see, then the circumference is intersecting, right? The circumference is intersecting this grain. So this means this grain cannot be considered as N1. But this grain, see, this is one of the grains where the which is not in contact anyway with the circumference. So this grain you can consider this as N1 because this is the grain which is completely within the circle. Okay, right? I mean, similarly, this is also within the circle. This grain also is completely within. So all these grains through which the circumference is not passing, that is within the circle, is equal to N1. Now, what about those grains where the circumference is passing through? So that is N2, and number of grains within the intersecting within the circle. Now, just can you count what is N2 here in this case? Anyone?
$40 and $15, somewhat.
Yeah, it's 14, kind of. Yeah, I mean, there's kind of 14 only. Just count.
15. I mean, yeah, 14 to 15. Yeah.
Yeah, kind of. I mean, yeah, there is, because the grain boundary is, one of you said, no, it is a bit not exactly properly visible, but okay, maybe 14. Okay, if you take 14 also, doesn't make much of a difference. Okay, but okay, fine. 15 you can take in between. Okay, so if you suppose it is 14, so maybe if it is 14, then suppose n1 is 24, n2 is 14. Now what to do? Now Na is nothing but the number of grains per square millimeters. Now this concept comes. I mean, how you have to find out. Now suppose m is magnification. Now suppose I am giving you one example, that is m is nothing but magnification, and that is m. M in this case is 100x. You have taken this image at 100x magnification. Okay, and A is the area of the circle. So area, you know, because 79.8 millimeter is the diameter of the circle, so you know pi d square by 4. So you find out the area of the circle. No, A you know. Then what you have to do? Na you have to count, you have to find out, because this is the term that you have to find out. Because rest all the parameters you know. This is 24, this is 14, this is 100, 100x, and this is A. A is the area of the circle. So A is the area of the circle means 79.8 square into pi by 4. So you will get this value. Okay. So okay. Now the question is arising, that is, what is it? Small f. Okay, because Na is equal to f into n1 plus n2 by 2. Okay, this is n1 is n1 is not divided. Okay, so n1 is like n1 only. It is just n1. Just you have to divide the value of n2 by 2. Okay, so that is f into n1 plus n2 by 2. So what is the value of f? F is nothing but m square by a. What is m? M is the magnification. So if it is 100x, so it's 100 square divided by area. Area is what? Pi d square by 4. I mean, what is the diameter? 79.8 millimeter. That's it. And then once you get the value of Na, it is nothing but the number of grains per square millimeter. Then you will be able to find out what is the value of G. G is nothing but the average grain size, and that is equal to 3.3222 into logarithm. So this is base E. Okay, this is ln. This is ln. Okay, this is not log to the base 10. This is ln. Okay, not, you make a note of it. So this is natural log. Natural log of Na into 3.322 minus 2.95, and you will be able to get this value. That is the G value you will be able to get. Okay, so with this, yeah. So with it, this is clear, no? This is also clear, right? Is this
Yes,
clear?
sir. Yes.
So like we have to not go that deep in the formula, no? Just remember it.
No, just remember it. See, going deep into the formula, see, you need to know the application part. No, you just don't need to go that much deep in doing the research of how this formula has come. When you can find out, I mean, you can definitely do it. That is up to you. But I can also send you some of the derivations. But I mean, you don't need to go into that much depth. What you have to do, you have to solve a like you have to like I will give you, like I will show you this slide. This microstructure, you will see now. If you look at this microstructure, this is the microstructure that I have obtained from this Bueller website, and there the scale bar I have put it as around 5 microns. Okay, now what you have to do is that you have to calculate the grain size. This is magnification is around 100x. Okay, this is the magnification. 100x is the magnification. This is you have to do today in front of me. So this 100x is the magnification, and then linear intercept technique, you have to apply both the techniques to find out the average grain size. Okay, and when you take the linear intercept method, this is the this is the 5 micron is this thing is the scale bar that you have to apply. Okay, so that you can get the value directly in the micron. And you know, and the other one is the planimetric method. Planimetric method, I will tell you, like initially do not consider this scale bar. Okay, do not consider this scale bar. I mean, first you draw like for the planimetric method, the width is equal to the entire width. The width of this microstructure is equal to 79.8 millimeter. Okay, just consider that. Don't consider this scale bar for this planimetric, but for the first one you consider the scale bar, and then you tell me the answers. Okay, can you tell me? I mean, can you do it? When you are done with the answer, just switch on your video and show and like, no, don't have to show me. You can either switch on your video, or you can also tell me the answer also directly, or you can show the answer.
So could you repeat? I couldn't just follow. Like...
Yeah. I'm saying that, you know, here you have to solve the micrograph is given at 100x. Okay, this is the magnification. You have to find out the average grain size using linear intercept method and the planimetric method. Okay, so linear intercept method, I have given the scale bar 5 micron, and this planimetric method, when you don't consider the scale bar. You just find out the value in the I mean, you just have to find out the value without the scale bar. Okay, for the planimetric method, because planimetric method using scale bar, it might be tricky for you. So first you find out using the linear intercept method, and do it using this thing, ImageJ software that I told you to download yesterday. You guys
Yes,
are get the classwork, right? I mean, okay. But before that, answer one question. I mean, it's a very simple thing. What kind of an image is this? Can you tell me what which has been taken from which microscope? Do you think?
TEM.
No, TM will give you this. Do you think? 5 micron, man. Just imagine.
Okay, okay.
Electron.
5 micron.
SEM, I think.
SCM. Okay, SCM I can agree. Or optical also. Optical also it is
Yeah,
possible.
optical microscope.
Optical microscope, but it might be hard because if it is 100x you will never find 5 microns. It is mainly from SEM only. SEM, so scanning electron microscope only. Because why not optical? I will tell you. 100x you will never find a microstructure which is having a scale bar of 5 micron. You can find it out, but then I mean that is quite unnatural. I mean most of the cases you won't find an optical microscope. It is 100x. You will see a scale bar of around 20 microns like this. I mean this is just coming from experience. 5 microns will not be with like 100x will not give you 5 microns in optical. You can see this in SEM, that you can do, but then the SEM it is okay. Okay, now the question is the sample etched? Do you think? What do you think?
Yes, sir, it's etched. Yes.
Why do you think? Why do you think so?
Because we are clearly able to differentiate the grain boundaries.
Right.
That only happens when it's etched.
Okay, and what is your opinion about the processing condition? I mean, look at the grains. Don't have to calculate. Look at the grains, grain distribution, bimodal, right? I mean, this is a small grains. There are big grains. What do you think has happened in this microstructure? Just imagine. See, this is a small.
Some compression something.
What?
Compression something.
Compression will this thing. Compression you will get like the grains will become like a chapati. No compression, you don't get these things. No. What else? Simple. It is very simple. Don't have to go to compression that much extent. Very simple thing. Like, just tell me one of the conditions in which you can get this kind of a situation in any material. I mean, it's not in any material, but maybe simple. Copper, aluminum, maybe. What kind of processing? Simple.
So, like in some regions, it's very densely, like it's very crowded, and some regions are like they have very big grains. Like,
have you heard of recrystallization? There is one term, recrystallization.
Just heard, sir. Like I don't know about.
Okay. That's a point. See, that I will tell you. See, recrystallization, you will always see some equiax grains. Okay, you are seeing here, you are almost seeing some equiax grains. Okay, this is not equiax, but this is equiax. But this is also not that much, but still equiax. You can say this. And similarly, this is a big grain. See, and this is again a big grain. This is these are partially equiax. So you can say this is a partially recrystallized microstructure, right? Even this kind of a microstructure, you will say is partially recrystallized. So the opinion, the processing conditions is that the microstructure has undergone partial recrystallization. Right. So the material has undergone partial recrystallization. So that is the reason why there are certain pack of grains which are very small, where recrystallization is yet to happen, and certain regions where recrystallization has already happened or has already started happening. So those grains have started becoming coarse, but these grains are still small. So that is the processing condition. Is it understood?
Like coarse, sir, how do we make out like this is a coarse grain or like?
See, coarse grain only. I will tell you. See. Look at this. Look at the microstructure. See, you look at this grain. Okay, where my mouse is pointing. You look at this grain, the adjacent grain, and look at the top grain. What will be your opinion? This grain is coarse or this grain is coarse? This grain is coarse, right? That the upper grain is coarse.
Okay. Like in terms of size, you're saying, right?
Size. Coarse grain, na?
Yeah. Right.
Okay.
That is fine, and this is coarse, kind of.
Yeah, fine grain. No, but you see, certain regions it is fine, certain regions it is coarse, which means recrystallization has started happening in the coarse region, and in the fine region there might not be recrystallization at all. It may be possible. See, there is also another condition. I'm not going to that. The other condition is that maybe you have made the material. During solidification also you can get this kind of a microstructure. It is also possible. But then I'm not going to the depth of it. I mean, it is quite difficult because there are certain regions where solidification has happened at a faster rate, and certain regions where solidification has happened at a very slow rate. Okay. So if it is happening at a faster rate, you will get more nuclei. No, you will get more nuclei. You will get more finer structures. If it is happening at a slow rate, you will get less nuclei, and you will have bigger size trains. So in that is again the case, but don't consider that. I'm just asking, it's a partially regularized microstructure. Okay, I'm made it simplifying. Okay, so just tell me, just calculate the linear intercept using linear intercept and planimetric method. So you have around 15 minutes, 15 or 20 minutes. I can give you 20 minutes. 20 minutes is enough, I think. I just take 20 minutes and tell me the answer.
How many lines minimum do we take?
You see, it is up to your, but I think always take minimum around 5 lines.
Five lines.
Because that will that will be reducing the error. That will reduce the error. Otherwise.
Sir, how do we operate that this software image?
Okay. Okay, sure. So maybe I can show you. Sure. Maybe I will. No, I will only show you. So I think that will be good. I will show you. So let me open software. Okay, so maybe so this is you are able to see the image thing, no? This thing.
Yes, sir. Yeah.
So suppose I open the microstructure, this, and so just click on file, open. Okay, make a note of it so you can operate it. So it will be easier. So maybe how do I open this? Open this file. Okay, so maybe I will show you one of the images, then I can show you classwork. This one. Okay. Oh, this one. Okay, I saved it. Okay, good. So suppose no, but that will be no. This one is not calibrated. I will show you the calibrated one. Calibrated one is not this one. Yeah, the other one I'm saying. Wait. Maybe where? This one I can show you. This one I can show you. This one is another. This is another example. See, this is a very interesting microstructure. I'll show you. So suppose you take this, click on analyze, then click on set scale. Okay. See. Oh, sorry. You don't have. I made a mistake. You have to draw a line first. Draw a line. So just draw a line. See, look at the scale bar. Okay, I am just drawing a straight line, which is of the length equal to the length of the micron marker. No, this is the scale bar length. Okay, I'm just drawing a line equal to that. Then what you have to do? This distance equal to 30 micron. Isn't it? This distance in this microstructure equals to 30 micron. So what you have to do? Click on analyze, click on set scale, and then click on this thing. This one thing. Known distance. Don't have to worry. Sorry. I'm sorry. Distance in pixels is 81. Known distance you have to change. Known distance is 30. What is the unit? Unit is micron. So if you write micron, you can either write micron or you can also write If it is nanometer, you can write it as nm. If it is micron, you write it as always. Okay. I mean, micron also you can write, micron also you can write, but this is a shortcut, And known distance is 30, so I put it as 30. Known distance. That's it. Just click on OK. Done, right? Then what to do? So suppose I want to find out using the linear intercept method. I want to draw 5 parallel lines. What do you do? Draw a line here. Okay. So a straight line. You draw a straight line. Okay. And always remember that when you draw a straight line, it is always advisable to press the Shift key so that you are able to draw the straight line. Okay. While dragging the mouse, you always press the Shift key. And what you have to do is that you click on Control M. Control M. Okay. Control M is nothing but it will give you the measurement. See. The measurement, you don't have to worry about the area and all. This is the length. Length is 260 approx. 260 microns. Okay, this is the length of the first line. So similarly, let me draw the other line. Okay, I mean, if I am drawing the other line, it will be suppose something around. You see, the first line will be gone, but you don't have to worry. Just draw the first line, and again you click on Control M. So you'll again find. See, the other length is 261. I mean, see. That's the reason exactly I didn't tell you it is 260 all the time. There is some small error, 259.63, 261.11, so L1, L2, L3. So you can do that. And see, for the first case, how many intersections we had? 1, 2, 3, 4, and 5. 5 intersections initially we had. So this how many intersections in this case do we have? 1, 2, 3, 4. Okay, so how many intersections is 4? So 5 intersections for the first case, right? Second case, we have around 4 intersections. Now, similarly, you draw the third line. So here you have maybe okay. Okay, now let me again draw another line. So yeah, this line suppose. So how many intersections you have? 1, 2, 3, and 4. You see, this is another boundary. See, this is also another boundary. So total 4. And now what is the length that we measure? Length is again 259.259. So make a note. Okay, you always make a note. So L1 is equal to this number of intersection for the first line is equal to this. Similarly, L2 is equal to 261.11. The number of intersections for the line 2 is equal to this much, 4. No, 4. Third case, now L3 is equal to 259.259 and the N3 is equal to 4. So like this, you draw minimum 5 lines, but definitely my suggestion is if you want to draw 5 lines, I mean, just ensure that it is going to cover your entire thing. Like if you draw this line, then similarly, if you draw another line here, you draw another line here, you draw another line a bit down, so that it is going to cover your entire area of the microstructure. Okay, so ensure that. Okay. And then you can find out what is the average grain size. Like if you draw only 5 lines here, then this area you might miss out. Nah? If you want to draw 7, 8 lines, then you can do one thing. You can draw a line here, you can draw a line here, here. See, the more lines you draw, the more it will be your effort, but the more accurate results you will get. Okay. Is it okay with you? Understood, right?
Yes, sir. Yes, I understood.
So the other thing I will tell you,
Like when we get the length results, so then we put it in the formula and then we tell the final answer, right? Like that's the classwork.
That's it. That's a classwork. That is the linear intercept. And for the other case, you don't have to for the other case, I have told you that you don't have to worry about the scale bar. You just put it, you just draw a circle like this. Okay, I will. You can just close this up. I will maybe I will show you the demo once more. Because today I am not bombarding you with the scale bar in the second case. I mean in this planimetric case, but that is a bit tricky. It's not that easy. Maybe I will demonstrate in the same microstructure only. Where is that microstructure gone by the way? Maybe I can use this only. I don't need the scale bar. So fine. So I have it here. So what I will do, I will draw a circle. See the width. I told you that the width of this microstructure is 79.8 millimeter. So you draw a circle. So which is which is going to cover. Okay, so which is going to cover your this thing. So which is going to have a diameter of equal to 79.8 millimeter. Okay. Once this is going to have a 79.8 millimeter diameter, you can find out easily. So area you can calculate pi d square by 4. What you have to do, magnification I told you 100x. That is you already know. And now n1 you have to calculate within this circle how many grains, and then how many grains are through which this circle is passing. That is n2. Bas, that's it. You will be able to put it in the formula and you get it. Got it, right? I mean, this is your classwork. Okay.
Okay. So answer like do we need to submit anything, or like we just need to verify the result?
Yeah, just to verify the results with me now, and after this class, maybe when you submit your homework, submit your classwork also. We will make 2 different folders. We'll make a classwork one separate folder, homework another folder. That's it.
Okay.
Any more doubts regarding the classwork? You just ask me now.
Sir, software is not working for me.
Software is not working. Okay. Okay. Which system are you using? Mac system or what? Windows only. Then,
it is saying like you need to purchase Windows RAR.
RAR. RAR. I mean, you don't have to purchase it. I mean, guys, the other guys, is the same problem happening with you also?
No, like you just when you will download, there will be a zip folder, and then you have to just extract all them, and then it will open.
No, that's what. RAR to purchase. You just verify once or do one thing. But download the zip, WinZip. Download WinZip once. Okay, the WinZip I think you can do. I think WinZip is not. You don't have to purchase WinZip. I think for that. I mean, I in my computer. I don't have WinZip purchased. I have it, but I don't have it purchased. I have not paid for it. So there is no problem with that. It is already opening. You do one thing. If okay, if you are not able to do the classwork, maybe you try to do it. Try to put a scale or something. Put a scale on the on the computer screen, and then you can try to do it. I mean, that is the manual method. I used to do once. I used to do it like in a manual method. But okay, that is not scientific, but okay, for understanding. I just want to see your approach, how you are able to do it. That's it. Okay, so guys, you have like to till the 150. Okay, 150 the class gets over. So maybe I can give you 10 minutes. 10 minutes is enough, I think, for this. 145 is enough, and then I will explain the homework also. Not explain, just 1 or 2 minutes I will take explain the homework. That's it. So okay, 10 minutes you take. Okay, look at this screen, and then you can have some idea. You want to see the formula also? You can ask me. And go to the previous slide.
So basically, we had to find the points of intersection of the line and the grain boundary. Number of points of intersection.
Grain boundary. Linear intercepting.
Yeah. Okay.
You already know the magnification 100x.
Sir,
Yeah.
sir, how to ensure straight line in laptop? Like I don't have mouse.
That's okay. Okay, so laptop. Okay. Okay. Click on the shift. Okay, press the shift button, and then click on the touchpad. Okay, the left touchpad, not the left hand side where you right. You just press the shift button. It will be straight line only.
Okay.
Yeah, it will be a straight line only. If you press the shift button.
So can you show the formula?
Sure. Which formula you want?
Line intercept one. Yes, I got it.
Sir, should I, sir, I mean, I got one, like the value of capital D,
What is that?
0.0331 microns.
0.031. Are you sure? Again, please recheck once. 0.031. If it is, then it will be then it is a nanometer. I just you please recheck once. Okay. I will tell you the step by step. What is the length? How many lines do you draw?
5 lines.
5 lines. Okay. Can you tell me the lines? The length of the lines?
Yeah, 4 of them were 37.922. And the last one was 37 point, just a minute, 37.792.
Okay. And that line was passing through the entire.
Yeah. Like image, like from the left to right, proper. It was
Yeah. Okay. Then how come the last line was so short? Just
No. I mean, I just drew it like it touched the end. Oh, like there was no problem with that.
okay. Okay.
Even the angle was same. Like the max and all that was also same. Like the max came out to be same in in all the cases.
Okay. So now tell me one thing. Then how much was like is your n like all the ends? And can you tell me the value of n? That is the.
So like length. So yeah, I got for the first line I got 12 greens, 12 things. Next I got 16, then 23, then 22, then 19.
Okay. So what you have to do now is all the length you add. Okay.
Yeah.
Okay. Then add all the n together.
Yeah, sir. So like 37.922 into 4 plus 37.792. Yeah, that
Oh,
into.
okay. I forgot to mention one thing. Okay, I will tell you the other thing. Okay, I forgot to mention one thing. Okay, just make a note. Oh, that's what you got such a low value. Okay, I got your answer. Okay, so this the problem is if you have to divide by the magnification if you don't take the scale one, but since you are doing it in the image, that's what no. Since you are doing it in image J, I see that's what we initially took the scale bar as the calculated it. We already calculated.
Oh, okay. I understand. Yes, sir. Like we have already set the scale to that. So
yeah, so you don't have to divide by the magnification. So
okay.
all the students please take note. I mean, don't have to divide by the magnification if you take set the scale initially. Because if you set the scale bar, you don't have to divide by the magnification. That's the reason you got such a low answer. Otherwise,
yes, sir.
30 point something. I think you would have got around.
Sir, I'm getting 3.09 micrometers.
Okay, still again you recheck once. I will tell you. So you divide L by N. Again you divide L by N and just check once. I will just still 3 is still less. I will just check once. L by N how much?
So just a minute, sir. So that's 2.06.
Okay, 2.06. Okay. Then it is 3 only, right? Okay, 3 is fine then. Yeah, that's what I just see. I also don't know the exact right answer. I just want to see your approach. Okay, how much? What is your approach? So your approach is fine. So L by N, you're getting 2.06, and you just multiply with 1.5. Very good. Okay.
Yeah, like then I multiplied it with 1.5, then I gave the answer.
So that's correct only. That's correct.
Ah.
You see, I will tell you. See, the problem with all these methods. Okay, I will tell you the entire class that this kind of method is linear intercept. Okay, so guys who are done with linear intercept, try with this planimetric also. Okay, do the planimetric. Do the planimetric thing also. Okay, then you don't have to consider the scale bar. Okay, just draw the circle. Whatever method I told you, draw it and find out the answer. Okay, but see, for all the methods like this, I will tell you that the problem is you will find out the average value, but you will not find out how which grain is having how much size. I mean, you won't find out the distribution, right? And it's the distribution which is the most important instead of the average grain size. But okay, since you are beginners, I mean, all these methods are just going to tell you what is the average grain size. And average grain size, we people also find out, but see, error bar is always important. We will find out this thing. But okay, I mean, today you don't have to find out error bar. We'll find out this thing. So, see, first answer.
Sir, for just one thing, sir. So for the next method, like the radius. So how do we set the radius? Like because you wanted some specific radius, right? Like that 17.
Okay. Do one thing. I'll show you. Okay, I will again open that software.
Yes, sir.
So that you can understand. Just wait a minute. Let me open one of the images. Okay, good. So maybe okay. So what to do? No, this is not correct. Okay. Where is the image? No, this is the image. Okay, fine. So what you can do? You take this. You don't have to set the radius. You have to set the diameter, right? So see, just draw a straight line here. Okay, there is no scale bar problem here. So you just have to draw a straight line. Okay, vertical straight line. In the vertical straight line, what do you do? Go to analyze, go to set scale, and then you just change this 79.8 millimeter, na? 79.8 millimeter. That's it. And this is the because this is the diameter, na? Any circle that you draw, the diameter of the circle will be this, na? This will be the diameter, right? I mean, any circle you draw which is having the tangent
Yes.
here, like this only. So that's it. Click on OK, and then you take a circle, and then you start drawing it. So you just press the shift button, and that's it. When you draw the circle, also it is advisable that you press the shift button so that so that you don't I mean, so that you can draw an exact circle. Otherwise, many a times you may not end up drawing a perfect circle. Maybe you may end up drawing something else. So remember this thing. How is it coming that much big? I don't understand. What is happening?
Okay, so it should touch the top and the bottom. Like,
That's it.
Yeah.
See,
Right.
this is a circle, na? And then when you click on Control M, see the area you found out, no? This is the area, right? 79.8 whole square, millimeter whole square divided by 4 into pi. It means into pi by 4. So this is the value. This is the area. Still, you find out using calculator also. Use the calci also. Just check. Is this correct or not? 79.8 millimeter whole square. How much it will be? 4,900 into pi by 4. Isn't it? No, it is 80, na? So it will be 6,400 into 3 by 4. Okay. Yeah, I think it is correct. Yeah, I think it is correct only. Just check it. Okay, I will back. Cut this because you have to see the answers also, no? Means formula also, no? Guys, anyone got any other answer from this linear intercept? How much?
Sir, like I got the L by N value. Should I have to put M value also?
No. see, I will tell you. So if you have taken the scale bar initially, then you don't have to take the M. If you have not put the scale bar initially, then people take M. But generally don't do that. Okay, always don't divide it by magnification. If you have already used this scale bar, put it in the scale bar. So you don't just put L by N. What is that value that you have got?
0.37.
0.37.
0.37679. Like I have not I have just measured the line and that
Oh, okay. You draw. How many lines you have drawn?
5
5 lines. Still that you are getting
and
size.
like
0.37 is really not. Just check again once. 0.37 is a bit less.
no, so like L is the sum of all the 5 line lengths, no,
Correct.
and the big N is the sum of all the intersection of grain with each line,
Mhm.
big N.
Ah,
And then what like yes, so then 0.37 only coming.
okay, maybe you have taken it in a different region. Okay, do one thing. I will suggest you one thing. Okay, that is fine. I understood that you have understood the formula correctly. That is not a problem. When you do the classwork, I'm suggesting all the students that what you do, at least draw 10 to 15 lines. Better draw 10 to 15 lines. What you can get now, in that case, the chance of errors will be low because you will have lines passing through many of the grains. So the more lines you pass through more of the grains, you will get better answers. So I think just today's time was short. That's why I told you draw only 5 lines. But when you submit the classwork, draw at least 10 to 15 lines. So so that they are covering the entire width of the microstructure, so that you can understand what is.
So for homework, you're saying, right? 10 to 15 lines, like for homework.
Yeah, classwork also when you submit. Today's classwork when you submit, okay.
Right.
Classwork when you submit, you repeat this exercise with 10 to 15 grains, okay, so
Oh.
that all of you get almost the same answer. I mean, it is not possible now that all of you are getting different answers for the same. I mean, different answers you can get, but this much different. If it is 0.37, you divide it by, you multiply it by 1.5, it will be around how much? 0.45 or something. So 0.45, and you are getting around 3 microns. See? That is too much difference. So that's what I'm saying. 10 to 15 you draw for both classwork and homework, and then so that you can get at least some answers which can be comparable. It's not like 0.45 one is getting and the other one is getting 3. The third one is getting 6. The fourth one gets 9. I mean, that is very good. But I understood. I mean, this just today's exercise was just to understand that how much you have you have grasped this thing, and that's okay, no problem. Just for your answers, you just have to be a bit more hardworking to draw 10 to 15 lines. I understood the pain, but that's how it is. And you already have a software; it doesn't take much time. Okay, planimetric method. Anyone got anything? You are doing it or already?
Yes, I'm doing it but the thing is it's very dense in the circle, so it's difficult to keep track of the grains which we have.
In straight line also, if the grain become parallel to the straight line at some point, then we cannot it just coincide with the grain boundary. So how
it happens.
to deal with that?
See, in that case, I will tell you. See, if it is suppose if the straight line becomes parallel with the grain boundary, then you cannot take that. That's what I'm saying. You cannot take the intersection with that grain. So what you have to do in that case, you have to reduce the line spacing. If you want to reduce the line spacing, which means you have to increase the number of lines, to increase the number of lines, so that more and more grains you can connect with the grain boundaries. I mean, with the lines, So in that case, that's why I'm telling you to draw around 10 to 15 lines. Make it try to draw around 15 so that you can get more of the grains passing through the lines, right? So
if they are if the line is coinciding with any one of the grain boundary, then we have to take the intersection or not? We leave that
yeah. We have to take one.
One intersection only.
Yeah, because see, it is only passing through means only one point of contact. It is only passing through one point of contact, not through 2 points of contact. So whatever point of contact it passes, you have to take only that.
Yeah. Okay, sir.
So that's what.
So what do we do in the next method? Because it's actually how do we keep track of the number of the grains which we have counted? Because it just gets difficult to just keep.
I mean, see, there you have to be bit more. I mean, see, you can try doing one thing. Maybe I can give you one trick. The trick is you take using this image or else. I mean, see, you have to do it manually. Actually, if it is image J, then you have to do it manually. I mean, manually you have to keep track, or else what you can do, you take some, if you have like, if you are having some tab or something that you can mark on the screen, like, mark on the screen, like, so you have some whiteboard marker you have, na? If someone's computer, you can have, this, like iPad, you can have which grains you have counted, 1, 2, 3, you can mark that.
So is there any option of like the coloring here? Like
Coloring you can do, but inserting text, I don't think it is possible.
Not a text, sir. So if you just have like some kind of color, then you can keep counting as well as marking so that we don't count it again.
Yeah, I understood, but then I don't think that is possible. In image, that is not possible. Not possible. No, it's difficult. I don't think image they have not given this this thing.
It's like color picker. Like there's a color picker option.
Yeah. And that's what, no, see, many of the people, mostly we never use this planimetric method. See, planimetric method, the problem is the same problem that you are highlighting, the same problem where people were going to face. But okay, since you are starting it, that's why I just, I'm focusing on that. Otherwise, mostly people use this linear intercept only. It is very fast actually. So.
Yes, sir. Yes, sir.
You see, only 5 minutes remaining for today's class to be over. Just at least tell something so that we can wind up today.
Sir?
Yeah.
Sir, for value of D, I am getting 2.25.
Okay, small d, na?
Small d is 1.5.
Oh, okay. That's what I'm saying. So you
2.25.
Okay, so still that is comparable with the one of the like 3 microns and 2.25. Still that is okay. I mean, still it is near about okay. Okay, but still you can try with more and more lines so that you find whether your answer is consistent or not. Okay, so try with.
What's the actual answer? Like, what's the exact answer?
See, actual answer, I think I don't remember it now, but let me remember. Okay, yeah, the actual answer was around like initially they gave it around 4.5 or something they gave. Okay, yeah, 4.5. Yeah, they gave it around 4.5. So today only the answer that we got was around 3. I think they did it with around 12 lines or something. Okay. They did 12 lines. So. Okay, the second one, anyone got? You guys got it, no? Okay, I will show you the homework in between. So same thing, you have to do the same thing. This is your same microstructure. I just have one additional question, that is, you can address it in your assignment, homework assignment. Do the same exercise, like to find out the grain size using this linear intercept method and this planimetric method in this case. Okay, but this is this is a deformed microstructure actually. See, it's a deformed microstructure. You have you have stringers of second phase. Like, these are all the stringers. This is deformed microstructure. But don't worry. What I just want to know, what is the difference in terms of the number of phases and processing conditions between this image and the previous image? See, this image and this image. What number of difference in number of phases, and what is the difference in processing conditions? I told you the answer already. This is a deformed one. This is a partially recrystallized one. That's it. So do the same exercise. Okay. So guys, any one of you please ask this. Please tell whether you are able to get this answer by planimetric also or not. You're able to get it right or what?
Start.
We haven't counted the exact number of grains because we're just trying to count it.
Okay.
So what is the deadline for this?
Deadline is next now. So we can do, maybe we can give you deadline around this Saturday. Saturday night. No, Saturday night you can get. Saturday night. That.
So can you keep it Sunday night?
No problem. Okay.
Sunday. Thank you.
Okay. Yeah, see, I don't have any problem. I can give you unlimited time. But the main thing is that I have to answer the professor also. So.
Yes. So the number of phases, like we didn't learn that, right? Like the number of phases.
That's what I will tell you. In the next class, I will answer. Okay, in the next class, I will tell you. I'm just giving you this thing to do, because in this case, you'll be able to find out. Like you have to think yourself. Just see, look at the contrast. I will give you the hint. Look at the contrast. In this case,
yes,
contrast, and the first case, you look at the contrast. See, there is no contrast here.
Yeah, here it is plain.
There is a contrast. So how many phases? Two phases, right? Two phases here. Easily. See, the deformed phase, this is one of the phases. The other one, the matrix phase, it is having a darker contrast. See, there are two phases.
So aren't the three phases? I mean, the color gradation is.
You can. Yeah. That's what I mean. See here, looking at this, it might be hard to consider that there are three phases. Maybe because my practical experience is either there are three phases, or if there are two phases also, that is still possible, because one of the grains may have been over-etched. Okay, so one of the grains have been over-etched too much. So I think because of over-etching, I don't think this is because of the other phase. But still, I mean, to be on the safe part, you can say that here there are at least two phases. You can write there are at least two phases.
Okay.
There's no contrast. See, this is how you look at the microstructure in an optical microscope. Optical microscope also things will appear like that only. So, see.
So can we leave now?
You can leave, definitely. But still, you just okay, no problem. You can leave and just get the assignments done. Okay, so this by Sunday night you can submit.
Yeah, sure.
Yes, sir. And how do you submit it? Like in a PDF form? I mean, like scan.
Yeah. PDF.
So we just write the results, like whatever the
write the steps. See. Do one thing. Write the steps also. We want to see how how.
Okay. Okay.
So you have to write.
We make a kind of like the observation thing, and we just mention like the 10 to 12 lines, whatever 10 lines we've taken, and
that you can do. And you write what is L1, what is N1, what is L2, what is L2. Like you draw, like you show a schematic. You don't have to draw the entire microstructure. Just show a schematic that right? I mean, like a honeycomb, you draw all the grains, and just you show the schematic in how many lines, like parallel lines you have drawn. That's it. And then you can do this. Or else I can also give you one more option. That when you do it using this thing, you take a screenshot. You take a screenshot. When you draw the lines, you take a screenshot. Okay.
Because the lines will be there only one by one. Like the lines will be only by one.
Yeah. You take a screenshot, okay, and then you take maybe how many? If you're taking
2 to 3, 2 to 3 would work, right?
Correct. Yeah, that is enough. 2 to 3 screenshots you take, you attach, so that we can see that you have drawn lines like this, and then you have got the answer. So that is fine.
Okay, so we should make a folder in that classwork folder of our name. Then we should put the screenshot as well as the PDF.
PDF. And definitely when you write, when you upload your classwork, now always put your roll number also.
Yes. Yeah. Okay, sir.
Chalo, okay. Okay, so maybe today I think we are done then. Okay.
Yes, sir.
I will share this thing with you in the Google Classroom.
Okay.
Okay.